The domain of a function f of x is the domain of the algebraic expression given for f of x when we have a single definition or a single formula, and it's the set of all values which make sense in the formula. So we talked about the domain of an algebraic expression before, and when we generalize that to the domain of a function, we say the domain of the function is the set of all values x to which we can apply the function. So this also applies to piecewise defined functions and functions where the domain is specifically restricted. Sometimes we explicitly state what the domain of the function is. See this example where we say f of x is x cubed and x runs between 0 and 1. And we saw an example of that when we talked about a distance function for a car traveling between cities, and we said it was traveling at 60 miles per hour, and t was time given in hours after it had left the first city, and so therefore the distance it had traveled after time t was 60t, but it only maintained this constant speed for 2 hours, so the domain here was restricted between 0 and 2. So this formula only held for this particular example for t between 0 and 2. And here's an abstract version of that, where instead of having a story behind what the function is, we're saying f of x is x cubed for 0 less than or equal to x, which is less than or equal to 1, and that's it. That's the only x values for which this formula holds. So we've explicitly stated what the domain is here. And there are also times where we don't explicitly state what the domain is, and in that case it's implied or implicit in the definition that the function is, or the formula holds for the set of all real numbers for which the formula makes sense. So for example, if I say g of x is 1 over x minus 2, then it's assumed that x equals 2 is not in the domain. So the domain here is the set of all values of x for which 1 over x minus 2 makes sense, and that's all x values not equal to 2. Keep in mind when calculating domains or trying to figure out where a formula makes sense, 2 rules. We cannot have 0 as the denominator of a quotient, as here, and also we can only value square roots, or nth roots for n even, for numbers greater than or equal to 0. And both of these will help you figure out the domain of a function if it's not given. So for example, suppose we're given this function. The domain is not explicitly stated, so we'd like to know what the domain of this function is. Well, this formula will make sense as long as what's under the square root sign is greater than or equal to 0. So the domain is the set of all x values so that the formula makes sense. So that is, so that 5 minus x squared is greater than or equal to 0. And that's the set of all x so that 5 is greater than or equal to x squared. Now you can look at this 5 minus x squared as a quadratic and factor it and use a number line to figure out where this is true. I can also take the square root of both sides, and remember that that sometimes loses a little information for us, but in this case we can maintain the information because the square root of x squared is the absolute value of x. So this is x so that the square root of 5 is greater than or equal to the absolute value of x, or the absolute value of x is less than or equal to the square root of 5. And that's equal to the set of all x, so that minus 5 minus the square root of 5 is less than or equal to x, which is less than or equal to the square root of 5. So it's this closed interval between minus the square root of 5 and 5.